Hello, everybody. Nice to see you again online. This is Mathieu from Wayferi on a Pulse brand, and I'm really happy to have you here today for our first webinar this year on MoMas, how to power MoMas for 100% availability. Starten mal die Fräsi. So yeah, thank you so much for joining our old format, click meeting. You guys can drop questions in the chat, and we will collect them and answer them towards the end of the webinar. And let's dive right into the topic. So you've seen the trailer up front, but just to make sure everybody's on the same page, Wayferi is now part of a Pulse group, Wayferi a Pulse brand. And I'm sure most of you got the message, but just in case you wonder what Pulse is. So I always like to frame the topic of energy supply for mobile robots very simply. And there's a very simple rule why Wayferi is on the market and why we need chargers and wireless chargers and batteries. All in all, there's a very simple logic. Every mobile robot needs to be charged at some time. And often we forget that. Often we forget about how to manage and how to design a proper energy supply, which is going to work beyond the design phase, beyond the lab phase, beyond the 0 series, which is going to work for a large-scale deployment. So keep it in mind. This is what we want to achieve. Maybe a little flashback on what Wayferi is serving as industry. We are mainly focused on industrial applications, so warehousing, e-commerce, manufacturing. But specifically for the webinar today, we have some upcoming industries. And upcoming, I mean an upcoming of automation deployment. We have medical applications. We have food and beverage applications. Semiconductor and pharma. This is something we will emphasize on today. Paper and wood and oil and gas industries. And all of those industries have very specific requirements to safety. And safety is also a very specific requirement to charging. So keep it in mind when we will talk about benefits of the solution we are offering today, how this is being leveraged in semi and pharma and medical industry. And our target audience, our target customers are HV, AMR, mobile robots, OEMs. So we are offering components. We do some consulting and we do some, let's say, conceptual consulting for end users. But in the end, we are dealing with industrial trucks and mobile robots because we're a component company. And one thing which is driving us and driving, let's say, driving the commercialization of wireless charging is the vision of seamless power supply in the process. So the sketch you see here is not a MoMa, it's an automated pallet lifter, but the principle is the same. Charging is part of the infrastructure. Charging is not a dedicated process anymore. And this is something we will have a look at today, because in the use of MoMas, in-process charging, seamless charging, casual charging can be leveraged even more than with standard logistics application. So what's a MoMa? What's a mobile manipulator? It sounds a bit like a fancy buzzword, but if you look it up and if you browse the internet and look at the trade shows, mobile manipulators are really picking up very, very fast in attention, in deployment, in solutions which are being offered. And basically a mobile manipulator is nothing else than a mobile robot, and mostly a collaborative robot, which are patched together, mounted together, and together they become a mobile manipulator. So you have a robot, a 6-axis manipulator, which is not tied to a specific spot anymore. It can be moved around automatically or manually. And therefore, we talk about mobile manipulators. And again, if we do a little research, we will find that there are plenty of different MoMa designs out there. And the reason for that is that you have many mobile robots and you have many cobot suppliers, and you can more or less combine them however you want. And the point I'm trying to make here is that building a MoMa technically or physically is not a huge challenge. It's putting together two existing systems onto each other. But the challenge comes when you want to make a good business case out of it, because not every use case gives a good business case. And when we talk about building a business case for a mobile robotics application, we typically look at three main pillars. We talk about, and of course, focus on energy supply. We look at how can smart energy supply solutions make a solution more robust? How can we improve runtime? And how can we improve fleet efficiency? Those are the three main influence factors to make a use case a really good business case. And this brings us to our key challenge we have with the energy supply of mobile manipulators. So we've seen before that a MoMa consists of a mobile robot and a collaborative robot on top of it. And typically, the whole installation only comes with one battery, with the battery of the mobile platform. The cobot obviously has no own battery. So this brings us to the first challenge. On the day the mobile platform was designed, and specifically the energy supply was designed, they didn't consider an energy-hungry component on top. At that time, they considered two drive wheels and a couple of casters, and they considered driving around pallets or totes or boxes or whatever. And now we patch an energy consumption component, an energy consuming component on top of it, which was not originally designed for. And this leads to a significant reduction of downtime in terms of availability, in terms of driving and charging ratio. The second challenge which we face is that most of the AMR charging stations, the docking stations, are designed for offline charging. They are designed to be mounted against the wall in a dedicated area where the robots go and charge. Typically, where the robots do not fulfill any productive tasks. So with the existing charging solutions of most of the platforms, you cannot implement easily in-process charging. And this immediately brings us to a significant business case disadvantage, because this means we have some robots which are inactive in terms of process. So the first thing we want to improve, and this of course applies to mobile robots by themselves, but it's even more important if you have an expensive cobot sitting on top, we want to enable in-process charging. This means we want to make sure that the robot is able to charge, or the MoMa is able to charge while it's working. And this will bring us in a second to the problem with standard docking stations. So here we have two examples which you can Google up, which you can find online. They are not any proprietary setups. So the robot on the left is an Austrian company called Gear for Tech. It's a robot which is made to feed machining tools, so turning tools, milling tools, or milling machines, turning machines. And the idea is that while it's feeding the machine, it has a chance to getting charged. And same for the robot on the right from the German company Henkel and Roth. This robot has the ability to get charged while it's working. And this is the key to 100% uptime, to enable a setup by using the right technology, which allows you to have charging while the robot is doing its job. And The second important factor when you look at increasing robot availability is to upgrade charging current. So you want to have the highest possible charging current. High charging current means low downtime, short charging time. And in this matrix, in this table, we have the top axis is the charging current. This is a generic example. This has got nothing to do with what is charging. This is simply showing you how important high charging current is. So you have charging current on the top axis, and on the left axis, you have the average power consumption of the robot. So the first example is the line with 6 amps of average consumption. Let's just assume we have a robot, a solution with 6 amps consumption. If we would charge this robot with 20 amps, so this is the top left red circle, we would have 77% of availability. This means the robot is able to work 77% of the time. If we're able to upgrade charging to 91 with 60 amps, so triple the charging current, we would have 91% availability. So this is an absolute availability increase of 14%, 1/4. 1/4% of absolute availability increase is equivalent to 14% cheaper solution. This is, you can translate this directly in euros or dollars. Now let's look at the second example with 16 amps of consumption. This is more plausible if you start to have a cobot sitting on top of your platform. If we have a cobot sitting on a platform with 16 amps of average consumption, we would have 56% availability. If we are a bit aggressive here, this would mean the robot is only working half of the time. This means if you spend $100,000 on a robot, you have $100,000 sitting around half of the time. If we're able to upgrade charging current to 60 amps, we would have 79% availability. This is 23% absolute availability increase. This is a significant game changer in terms of making an investment decision on using a mobile manipulator, yes or no. So we've learned one thing. The business case of a MoMa strongly depends on its availability. The availability strongly depends on the charging current. And later we will see how we can enable both at the same time, opportunity charging with a high charging current. Now let's have a look at the first pillar of the business case house, which we call robustness. If we look at charging contacts, which have been used since many years in the mobile robotics industry and are still used a lot, we come across a couple of downsides of this technology. So we have wear and tear, we have bad contacting, arcing, we have tripping hazards, and all in all, those downsides are accepted in, I would say, like low-tech applications. Applications where we have maintenance staff around, where we have, let's say, not very demanding applications. If we recall the applications where we want to deploy mobile manipulators and where we can achieve a good business case, like semiconductor industry, pharmaceutical industry, high-end manufacturing industry, very likely we will not be able to accept those kind of let's say those kinds of hazards which are decreasing our robustness. So this leads us ultimately to the conclusion that charging contacts are not a very good design choice for demanding applications, and they will very likely significantly downgrade your business case. Let's look at one very specific example, clean room applications, semiconductor applications. There is a very good article which has been written by Mike Bachidor in March 2013, like roughly a year ago, in the US magazine called Control Design. And Mike looked at how to power AMRs and AGVs in clean rooms. The logic behind is exactly the same than mobile manipulators. So that's why I like to choose this example. And I have selected a section of this article where they discuss what could be upsides and downsides of using robots in clean rooms. And one conclusion here is that very likely in a clean room, you will not be able to use charging contacts, because charging contacts, by rubbing the copper or the brass contacts against each other, will simply generate some loose particles. And in ISO certified clean rooms, you simply have to stay below a certain threshold of particle emissions. So what is your choice? What are your options to charge or to use a robot in such an environment? Either the robot can leave the clean room for charging. Technically, this is feasible. You open a door, drive out, close the door again. From a business case perspective, this is the worst thing you can do. It is simply decreasing the availability of the robot by having it charging outside of the working environment. The other option, which is suggested in this article, is to use wireless charging. Wireless charging has the huge benefit, it simply doesn't emit any particles. And if we look at the Italink 3000 system, which we offer, our system is certified according to ISO 14644 cleanroom certifications by a Fraunhofer Institute. It has been certified for not emitting any particles. So if you would use such a system, or if you would choose to use such a charging system in a clean room environment, you would be able to charge in the clean room. You would be able to charge while you are picking and placing wafers or some other, let's say, extremely cost-intense materials. And this is the game changer when you design the business case of a mobile manipulating application. Simply choose components which allow the robot to work in the demanding environment you are serving. So how do we realize this technically? What components are needed to do this? If we look at robots available on the market, this is a simple Google research. This is not a specific project we've been working on. You typically see two ways to do this. The top robot you see has two sets of charging contacts. So this already shows that the cobot sitting on top of the robot needs an additional energy source. The platform which is used to drive around the cobot is obviously not able to provide either enough capacity or enough power to power the complete system. To me, this is simply showing that the system design of the complete solution was not made as in a holistic approach. If you look at the robot on the bottom left, it has one energy system. This is a way more integrated solution. So the cobot is powered by the platform. And obviously, there is a benefit to both of the solutions, but there is an even better way to do this. If we look at all of the cobot applications out there, they all have, I'm just going to show again the overview of the robots we found online. I would say that 90% of the robots here have some big chunky box sitting between the platform and the cobot. This will very likely contain some control systems, some PLCs, some power supplies, some vision systems, or let's say the CPUs for it, etc. And if we think, or if there's obviously a demand for such a box for some control systems, why shouldn't we use this box to add the additional energy components which can be used to power the complete solution? If we just imagine having this box in the middle equipped with some additional batteries and with a central wireless charging solution, we not just add additional battery capacity to power the complete solution, but we can also embed a wireless charging solution which will allow us to opportunity charge the complete system at each process stop where the robot is stopping anyway. So let's assume this robot does a bit of pick and place here and there. If we identify the pick and place stops or spots where it sits a little longer, like a couple of minutes, 5 minutes, 10 minutes, we would implement a charging spot there. And in this time, we would energy boost the complete system, because of course we would select batteries which are able to be fast charged. We would select a charging system which has a high charging current. And in an ideal world, this would lead to 100% uptime for the complete system, making the end user, making the end customer happy, because he would utilize the system in the best business case possible. So how do we do this? As Wiferion, we've always been very focused. We only offer chargers and batteries, the necessary consulting, the necessary field service, but we do not get distracted by the whole periphery. So we have a 60 amp charger, we have a 1 kilowatt charger, which is being launched just those days. It does 42 amps at 24 volts. And we also offer suitable batteries, which are perfectly matched to those chargers. And with those components, you're able to equip your mobile manipulators in such way that you are able to achieve 100% uptime. What's the benefits of wireless charging, let's say, in general, generically speaking? We have a high IP rating. So we could have the robots, for example, either operating outdoors or being thoroughly washed, like needed in medical applications. We have one charging solution which is able to serve different voltages. So if you would have a robot with a 24 volt system or a robot with a 36 or 48 volt system, you could use the same charging stations. Of course, the system has a very good efficiency, which is necessary nowadays to save energy costs, but also to have an acceptable CO2 footprint. We have an extremely fast charge begin, so even small stops, even very short stops can be utilized. The systems can be omnidirectionally approached. So if you would charge from the bottom of the robot, you could approach in any orientation, you could approach from any direction. Gives you a huge freedom of routing layout. And we have a very high positioning tolerance. And this is the key for a very simple system design. So I've learned that most of the cobots are vision driven. So they do not stop at a specific absolute position. They stop at the pretty coarse position, and then they have a vision system making a secondary positioning referencing so that they can pick and place even small components. If you implement such a feature for your cobot so that the platform can position coarsely, why shouldn't you implement a charging solution which also accepts this coarse positioning so that you can charge at any position which is implemented for the cobot? Of course, we want systems which do not generate sparks or arcing, which do not need any cleaning, and who do not wear and tear out. This is more or less obvious that wireless charging allows all of those benefits because there's simply no contact. Last but not least, I would like to emphasize on a specific benefit of wireless charging. It's interoperability. If today, in a mixed fleet environment of mobile manipulators, automated forklifts, tow carriers, underdrive mouse, and however you want to call all of those AMR types out there, at one point or the other, as an end user, you will want shared infrastructure. And shared infrastructure does not only mean harmonized conveyor heights or shared fleet management solutions. It also means shared charging infrastructure. And wireless charging is one of the options which allow you to use the same charging spots with different types of robots, of course, which are equipped with the same charging solution, but then they can all share the same charging stations. I have to apologize, this this little this slide should be a GIF, an animated GIF, and it doesn't play in the webinar. But I think you can imagine what happens in front of this conveyor. Different types of robots stop to take over a pallet or just stop there to get charged. But they have one thing in common. They all use the same charging spot. And we're coming towards the end of the webinar. Half an hour is pretty short. And I would like to thank the creative team of Wiferion for putting together this really fantastic white paper. Feel free to download it on our website. Feel free to reach out to us if you want to discuss the content of it. And I would say we're going to look at the questions which have been raised now towards the end of the webinar. So, okay, somebody's asking what is the impact of, let's say, many charge sequences or intervals on the lifetime of the battery. The question cannot be answered in general. The question has to be answered battery specifically. So I can only speak for the batteries we are offering, the LFP batteries from the company Murata. And we have a guarantee that the individual charging sequences can be added linearly with each other. So this means 10% charging means 100% charging. And typically, and in our case specifically, the lifetime of the battery is given on full charge cycles. So the battery we are offering has at least 7,000 full charge cycles. So I let you do the math, what this means if you do charge steps of 5 or 10%, how many charge cycles and lifetime this would give you. So the next question is one energy system an exclusive feature for Wiferion wireless against similar wireless product? This is a question I'm not 100% sure how it's meant, but I'm going to answer how I think it's meant. So Wiferion charging stations work with Wiferion mobile chargers. It's a closed ecosystem for the moment. Nobody's saying that this is going to stay forever, but at the moment, our stations and our mobile receptacles have to be from Wiferion. But our mobile charger works with any type of battery. There's no closed ecosystem here or let's say lock-in effect. You are not tied to use our battery. You can use our charger with your battery, and you're also invited to use our charger with our battery as a complete solution. Perfect. So there is another question. CoBots will have their own power supply, which in general, it is like a panel, and this may be built in the AMR AGV. In this case, is it possible to just use one system, and this system will also power the supply for CoBots? So, very good question, because you often have mixed brands of AMR platforms and CoBots. There's no general answer to it. I would say in general, the CoBot is pretty power source agnostic. The CoBot is designed to be used initially in a stationary manner. So either used with a 110 or 240 grid connection or with a DC input, something between 24 and 60 volts. Yeah. So the CoBot typically doesn't care where the power comes from. The robot itself has its own battery and its own charging system. So either the robot, the AMR has an outlet to power the CoBot, and then you already have a closed loop system. And now the power kit we're suggesting can come and sit in the middle and power either only the CoBot on top, or we can also backfeed energy down to the AMR platform so that you become completely agnostic of the OEM docking stations. And it's up to you. It's up to typically the system integrator will suggest a system design, but our power kit we are offering here, our concept, can power either just the CoBot or just the AMR or both of it. There's no limit here. Beautiful. So thank you so much for listening in. Thank you so much for joining today. I'm sure we could have plenty of more discussions and questions here. I want to drop that we're going to be present at the Automate show in Chicago in 2 weeks from today, and we will have staff there, which is able to talk and to consult about the use of our charging system. And of course, you can reach out to our representative team in Europe or in the States or around the globe about the Pulse team. So feel free to reach out to us via our website or via the Pulse website directly, and talk to you soon. Thank you so much for joining.